This is second numerical on Rankine-Jordan's formula. First read this numerical and understand it. A hollow cast iron column 5 meter long is fixed at both ends. Material of that column is hollow cast iron and this is 5 meter long column and boundary conditions are both ends are fixed and has an external diameter 300 mm. So they given us that external diameter in that numerical. The column supports an axial load of 1200 kN. Find the internal diameter of the column. So this is our objective. Find internal diameter. Assume alpha Rankine constant is 1 upon 1600 for that cast iron column and sigma c, that crushing stress, is 550 MPa. So our objective is to calculate that internal diameter, because see, we know that this is hollow circular shape column. So due to that, see, otherwise we can just draw it like that. So this is circle and other is we can do like that. So like this is hollow cast iron column of external dia 300 mm. And boundary conditions of this column are one end is fixed and other end is also fixed. This is column and length of that column is 5 meter. The hollow cast iron column 5 meter long is fixed at both ends, has an external diameter 300 mm. The column supports an axial load of 1200 kilonewton. So this P is 1200 kilonewton. Find the internal diameter. So find this. D is internal diameter. Alpha is Rankine constant, is given quantity, and sigma c is 550 MPa. So how to solve this numerical? How to get this D? For that, so we know that this formula PR is equal to sigma C A upon 1 plus alpha into LE by K square. Sigma C is given quantity. A we will find with the help of that formula. A is equal to pi d square by 4 minus pi small d square by 4. So pi by 4 is common, d square is 300 square and minus small d square, like that. This alpha is also given quantity. This LE that means see, this is boundary conditions of that column is both end are fixed. That means this column buckle like that. So that means LE is equal to L by 2. So L is 5 meter. That means LE is 2.5 meter. And this K, how to find this K? We know that K is equal to under root of I upon A. I is nothing but the moment of inertia and K is nothing but the radius of gyration. K is equal to under root of I upon A. So K square is equal to I upon A. So this I is nothing but see this I now. I is nothing but the moment of inertia for that hollow circular shape pi d raised to 4 by 64 minus pi small d raised to 4 by 64. So take this pi by 64 common. This 300 raised to 4, this is capital D minus small d raised to 4. So okay, so this K square is equal to, put this I in this K square formula, pi by 64 300 raised to 4 minus small d raised to 4 divided by pi by 4 300 square minus small d square. So see this 4 by pi sigma C A. Okay, just rearrange it mathematically. K square is equal to pi by 64 into 300 raised to 4 minus small d raised to 4 into 4 by pi and divided by 300 square minus small d square. So this pi get cancelled and this 64 upon 4 is 16. So 1 upon 16 is remaining. So here only 1 upon 16 is remaining. So now put this all in this PR formula. PR is equal to sigma C is this 550. Area is nothing but the pi by 4 into 300 square minus small d square. Divided by 1 plus alpha 1 upon 1600 into LE square. LE square is LE is this 2.5 meter. That means in mm it is 2500 mm divided by pi by 60 here this 300 raised to 4 minus small d raised to 4 upon 300 square minus small d square into see this 1 by 16 also 300 raised to 4 minus small d raised to 4 divided by 300 square minus small d square, and this 1 by 16 take here this side, so this is only 16. Okay, So this PR is equal to, calculate this, sorry, no, not numerator, calculate this term, this 1 by 1600 into 2500 square into 16, so it is 62,500. So 550 multiply by pi by 4 into 300 square minus small d square upon 1 plus 62,500, and this denominator term multiply it to that, so into 300 square minus small d square divided by 300 raised to 4 minus small d raised to 4. So now calculate this with the help of engineering calci. So first put bracket to all these terms. Now 550 into pi by 4 into 300 square minus alpha d square divided by 1 plus 62,500 into 300 square minus d square divided by 300 raised to 4 minus 4d raised to 4, bracket complete, again bracket complete, again bracket complete, shift solve. So this PR, sorry, our objective, how we will calculate this PR, because we don't know this D. So our objective is not to calculate PR, our objective is to calculate this D. So we have that PR, see, 1200 kilonewton. So put that 1200 kilonewton in mm. Why in mm? Because see that this 300 is in mm, so that's why directly put here. One two zero zero into 10 raised to 3. Okay, calculate this D. So in engineering calcic, put 1200 into 10 raised to 3 equal to 550 into pi by 4 into 300 square minus d square, bracket complete, again bracket complete, divided by 1 plus 62,500 into 300 square minus bracket complete, again bracket complete, again bracket complete, shift solve. So this, we will see what is this D internal dia value. See, articulation of solving this numerical. First what I did, that I remember that formula, and thereafter I saw in that formula what is necessary for me to solving this numerical and how to solve this numerical. So first I saw this formula, then I found that this small d is in this area and is in this k available. So due to that, I put that a and k in this formula, and this sigma c le alpha is given quantity, and as per that way I solved it. So this engineering calci gave me answer that internal dia is 293.66, and this is in mm. So that way our numerical completed. Our numerical is completed. So check that answer. Wait for a second. Is it correct? Yes, this is correct. So see that hollow circle, that boundary conditions, with the help of that boundary conditions, that we had get that L is equal to L by 2. We we had calculated that, we calculated that area by using that geometry. We, we calculated that moment of inertia by using that geometry. So that area and moment of inertia dependent on geometry, that effective length is dependent on boundary conditions. So for solving this numerical, we need to remember that for which boundary conditions, which effective length formula, that for different geometries, area formula, for different geometries, moment of inertia formulas, for that Jordan formula, Rankine Jordan formula. So as per that way, like, you will able to calculate this numerical. Thank you very much.